All right, everyone, and now this is your a little tutorial on to try to find the number of solutions a system has. So, one of the drawbacks of certain problems is that they have many solutions, and one of the big keys to a problem with a system of equations, if it has fewer equations than it does variables, then it's guaranteed to have many solutions. And this is one of those cases, and it's our job to figure out how many solutions this problem has. We've got a restaurant owner that receives a package of silverware containing knives, forks, and spoons. And you can read the rest that's on your screen there. And what I would suggest is that since we've got three different items here, let's just go ahead and make our X, our Y, and our Z each one of the utensils. And to come up with a quick little tutorial here on getting the two equations that you're going to get, you know that you have 40 utensils total in this box. So X plus Y plus Z should equal 40. And you know that the box weighs 141.3 ounces, and you have weights for each one of the utensils there. So 3.9x plus 3.6y plus 3z, that's going to be 141.3. All right, now if you're using a matrix to do this particular problem, then what you want to do next is you want to go ahead and construct your augmented matrix as though you're going to do reduced row echelon form, sometimes known as Gauss-Jordan, or even just row echelon form, Gaussian elimination. So here's how I build my augmented matrix, and I am less than pleased to see decimals in this scenario, but that's okay, I'll just deal. So not a bad deal here. What we're going to do is we're going to do one row operation, and our row operation is targeting the idea of getting rid of this 3.9. If I can just get rid of that, then I could solve for y in terms of z, and then I can backtrack and get x in terms of y and z as well. So let's go ahead and do a row operation here, and that row operation is going to be a multiply and add scenario. So I'm going to take negative 3.9 times row 1 and add it to row 2, bearing in mind that row 1 is going to stay the same. Okay, so now that I'm doing that row op, here's what the result of that is going to be. I'm going to end up with a 0 here, which is what we planned, and then negative 0.3, and then negative 0.9. And when I multiply 40 times negative 3.9, I get negative 156. And then when I add that to the 141.3, I'm going to get negative 14.7. So that's going to give me a chance to solve this system in terms of y and z. So once again, I have two equations. I have x plus y plus z is equal to 40. And now I have negative 0.3y minus 0.9z is equal to negative 14.7. So this is now the equation I want to solve for y, but unfortunately it's going to be just in terms of z, because I can't really know what z is right now. It's one of the things that makes this a dependent system. We'll talk about that in just a moment. So let's move the negative 0.9 over to the other side. And then I'm going to divide everything by 0.3, negative 0.3, and I'm going to get 3y, that's negative 3y plus 49. All right, so now I have an expression for y, and now I have to go back, and I'm going to have to put this into the equation, the first one, in place of y. So this is going to run a little out route here, so to speak, up until we get to the y. And I'm going to have x plus, and substituting in for y, that should be a z right there. I don't know what I was thinking there, so that's a little bit better. So this is going to be negative 3z plus 49, and then I have plus another z is equal to 40. All right, so I'm going to gather my terms. This is x minus 2z plus 49 is equal to 40. And now I'm going to move everything over in one clean fell swoop, and I'm going to get 2z minus 9. So what I now have is I have an ordered triple of 2z minus 9 for x, negative 3z plus 49 for y, and then z is just sort of a parameter, an independent floating variable. So again, what we're going to do is call this a dependent system. Okay? And what that means is that I can get all the solutions to this system, but I just have to pick a value for z. And as long as I pick a value for z, then the values for x and y will fall in accordingly with what my choice is for z. Now, here's the catch though. In a problem like this, when we're dealing with tangible objects, all variables must be positive integers. Okay, now what does that mean? That means that we have to have whole number positive numbers to be able to solve this system, because in the context of the problem, it really doesn't make sense to have like, 2/3 of a spoon, for example. It would just really throw everything off and probably annoy the restaurant owner to no end. So in order for us to figure out what it's going to take for this to be positive and also for this to be positive, I just have to take those and set them greater than or equal to 0. So 2z minus 9 has to be greater than or equal to 0. And negative 3z plus 49 has to be greater than or equal to 0. Now, lucky for us, these solve exactly like equations do, with that little caveat that if you have to multiply or divide by a negative, then the inequality sign gets flipped. So I'm just going to move the z over here, or move the 9 over, and z is going to be greater than 4.5. And then for this one, if I move the 49 over, which is what I was talking about a moment ago. Okay, now a little warning here. I've got to divide by a negative, so that means I'm going to have to flip that inequality sign around. I'm going to get z is less than or equal to 16 1/3. Okay, so for the purposes of this problem, we have to know that half of a knife, or half of a spoon rather, just really isn't going to do the job. So I would say that z really has to be greater than or equal to 5 whole spoons, because if it's less, then z will turn one of these values negative. It'll turn the x value negative, and we can't have that. And z can't be any bigger than 16, because if it's bigger than 16 1/3, then it's going to really have a problem with turning this particular value negative. So we're limited to picking a z that falls in between 5 and 16. Otherwise, we're going to have some value that's negative. So in order to get the final number of solutions to this problem, the different combinations that work, there's an easy way to do this. You're going to take the high z number on your inequalities and then subtract the low one, and then you're going to add 1 to it. So in that case, I'm going to do 16 minus 5, and then I'm going to add 1 to that, and that's going to give me a grand total of 12 solutions to this problem. Now, I could list all of them out, okay, and that would be kind of painful to do, but we'll do that here just for a couple of examples on the next page here. All right, so here we are with listing off all of the solutions really quick, and I'm going to spare you a lot of pain and suffering here, just maybe do a couple of them. We know that z needs to be between 5 and 16, so I'm just going to do a couple in each direction here. So if I pick 5 as the number of spoons in my box that I ordered, then I have to put that in for z for my number for x. I'm going to get 2 times 5, which is 10, 10 minus 9, which is going to give me 1 of the forks. And if I put that in for, put it in the wrong spot here. Give me 1 second. Okay, so if I put that in for y, if I put that in for y right here into the y expression, I'm going to get negative 15 plus 49, and that's 34. And that's going to make up the entire box of 40 utensils right there. Okay, now what if I pick for z to be 6? Well, if I pick for z to be 6, then I'm going to have 3 forks. And that means I'm going to have 30 of those knives, I believe. Hang on just a moment. That doesn't seem right. Negative 3 times 6 is negative 18. This would be 31, so I miscounted there a little bit. So at the back end here, if I pick negative 16, or 16 for z down at the bottom, and figure out what the others are, I'm going to have one of those be a knife, and the rest of them will be forks. There will be 23 of them all together when it's all said and done. So, I could get 4 of those knives. And then that means I'm going to have 21 forks. You get the idea, but just so long as z falls in between 5 and 16, we're in good shape. All right, there's your tutorial, and enjoy.